Here we go, your YouTube review for the microscopic anatomy of bone. Uh, Bone can either, on a histological or tissue level, be compact bone or spongy bone. These two we contrasted in this PowerPoint. The honeycomb network of fine bone structure that we saw here is called trabeculae in the spongy bone. Compact bone we looked at under the microscope, and we'll look at again later in this PowerPoint. The basic structure of a long bone, such as your humerus, consists of a shaft and two epiphyses, one on either end. The diaphysis is made primarily of compact bone. Within that compact bone is a medullary cavity, and within that cavity is yellow bone marrow, which contains fat. In the epiphysis, you see spongy bone, and that spongy bone contains red marrow. The surface of the bone is at the tips, where the bone would form an articulation or joint with another bone, is covered with what's called articular cartilage, which cushions the joint. In between the diaphysis and the epiphysis is the epiphyseal line, sometimes called a growth plate. And this is important as a site that starts out when you're younger as cartilage, and that turns to bone later in life when you are done growing. We looked at the structure in depth in various worksheets and a coloring diagram. You have proximal and distal epiphysis, diaphysis, medullary cavity with yellow marrow inside, compact bone in the shaft or diaphysis, spongy bone in the epiphysis, articular cartilage at the epiphyses. We spent a lot of time talking about the periosteum, which is kind of a latex glove, which is glued down by Sharpie's fibers. The periosteum is made of dense regular connective tissue. The cells that produce the bone tissue emanate from the periosteum, osteoblasts and osteoclasts. The periosteum also supplies the bone with needed blood and nerves for nutrition. And they did mention Sharpie's fibers, which kind of velcros the periosteum. Endosteum was mentioned on the as an epithelial lining on the inside of the bone, bordering, meaning inside. In the non-long bones, you're more likely to find that spongy bone in the red marrow. We mentioned how when you're young, when you're an infant, the red marrow is much more common as your body is ramping up its red blood cell production. As you get older, the red marrow is more limited, found in the flat bones and in the head of only these two principal. Looking at the bone tissue microscopically, that route of nutrition for that blood starts via a long central canal, branches off to a Volkmann's canal, and then to a canaliculi. I did modify this PowerPoint to put this in the proper order. These canaliculi then connect each lacuna with that blood supply. Inside the lacuna are the osteocytes, and the general matrix-like tissue found in bone is laid down in layers that are called, and you can see most of those here. Again, we spent some time with the canals. Central canal at right angles to that would be a Volkmann's canal, and then emanating from those would be find their way to each and every lacuna. And in here we have representations of osteocytes or osteoblasts in those lacunae. Central canals are obvious here. Lacunas are also obvious. Lamella are the layers laid down around the central canal. Even the canaliculi are fairly visible here as these thin hairline canals in the bone, throughout the bone. The contrast of the cell types and their suffixes: osteoblasts and osteocells, bone-forming cells. They would deposit, we call these the makers. They produce the bone tissue, and the osteoclasts break down the bone, reabsorb and break it down. And these cell types, osteoblasts and osteoclasts, are always in balance. Working to maintain proper calcium in the bloodstream as well as proper calcium in the bone to ensure. That's it.